Hello physics students, sorry. This is your formula challenge worksheet, homework assignment that you have. Again, my suggestion is you try this on your own and then you can watch the video to see if you did it correctly. You could watch the video as you do it and pause it, do your problem, and then play it, watch the problem, make sure you did it correctly. Okay, so here we go. First one. What do the following units represent? Use D for distance, T for time, S for speed, or A for acceleration. And the key to this really is looking at our units. So, in our first one, our unit is kilometers, which is a measure of distance. So this is a D for distance. Number 2, meters per second. That is a speed because it's a distance per time. So if we kind of make some notes here, right? Distance. Speed is going to be distance per time. Okay. Time is going to be just time. Okay. And acceleration is a velocity or a speed per time. So in this one there should be kind of 2 time units because velocity or speed is some distance per time and then you have time again. So in number 3 we just have minutes, which is a unit of time. Next we have hours, which is just a unit of time. Next we have centimeters, and that should be seconds, seconds squared, kind of like that. So again, that has 2 times in it, so that's an acceleration. Next we have miles per hour, which is a distance per time, so that is a speed. Next we have miles, that is a distance. Next we have seconds, which is a time. Next we have feet, which is a distance. Next we have meters, which is a distance again. Now we have centimeters per minute per second, so that's 2 units of time, which means that's an acceleration. And kilometers per hour per second, which again has 2 units of time, so that is an acceleration as well. The next one asks us to solve each problem. Be sure to show your work. Goldie Goldfish, a speed swimmer, loves to race around the park's pond, which is 0.5 miles around. If she can swim 20 laps around the track in 2 hours, what is her average speed? So again, I like to pull the information out of the problem, right? And we know she does 20 laps. And we see that each lap is half a mile around. So for her distance, it's going to be 0.5 miles times 20. Okay? Because she does that 20 times, which is 10 miles. Right? 0.5 times 20 is 10. Okay? And then the time is 2 hours. And we want to know what her speed is. So remember, our equation for speed is our change in distance over our change in time. Our change in distance is she goes 10 miles. Our time is 2 hours. So 10 divided by 2 is 5 miles per hour. "14. It takes Stu, a slimy slug, 20 minutes to travel from his favorite bush to the local trash can, a trip of 30 meters. How far can he travel in 1 hour, which is 60 minutes? Okay. So, again, they give us some information. So, the change in time is 20 minutes. Okay. His favorite bush to a local trash can, a trip of 30 meters. So his change in distance is 30 meters. How far can he travel in 1 hour, 60 minutes? Well, first we have to figure out what his speed is. So to figure out his speed is his change in distance over his change in time. So he can go 30 meters in 20 minutes. 30 divided by 20 is 1.5 meters per minute. So now we know about the slug's speed. The question is, how far can he travel in 1 hour? So we want to know his distance, which is going to be his speed times his time. Okay. Which, again, you have on your manipulations. So we know his speed is 1.5 meters per minute. And we know that the time, because we want to know how far he could go, right? So our question is, our distance is what when our change in time is 60 minutes. So if he has 60 minutes to travel, how far will he go? So times 60 minutes. And 1.5 times 60, okay, is 90. So he will go 90 meters. "15. At exactly 2 o'clock p.m., Speedy the snail crawls onto a meter stick at the 10 centimeter mark. If he reaches the 65 centimeter mark at exactly 2:10 p.m., what is his speed?" Okay, so again, the information they gave us is our first time is 2 o'clock p.m. Our second time is 2:10 p.m. So our change in time is 10 minutes. Correct? Everybody comfortable with that? 2:10 minus 2 o'clock. Okay. We know that his change in distance is 65 centimeters because it tells us, or not quite actually, sorry, I need to fix that. Okay. We know that his initial spot where he starts is on the 10 centimeter mark, and his final spot that he ends is 65 centimeter mark. So our change in distance is the difference between those, which is 65 centimeters minus 10 centimeters, which gives us 55 centimeters. So we want to know his speed. Our equation for speed is our change in distance over our change in time. We figured out his change in distance to be 55 centimeters. His change in time was it took him 10 minutes. 55 divided by 10 is 5.5, and my units are centimeter per minute. So he really is a pretty fast snail. "16. If it takes Leaping Louie 5 minutes to jump 3 blocks." Okay, so we know that a change in time is 5 minutes. My change in distance is 3 blocks. How long will it take him to jump 15 blocks? So I want to know the time if he has to go a distance of 15 blocks. So I need to figure out his speed first. So his speed is his change in distance over his change in time. And he's going to go 3 blocks in 5 minutes. 3 divided by 5 is 0.6. So he goes 0.6 blocks per minute. Now we'd want to know the amount of time it takes him. So that's going to be the change in distance over his speed. I'll use an S there, this S. So his change in distance is 15 blocks divided by his speed, which is 0.6 blocks per minute. So 15 divided by 0.6 is 25 minutes. So it's going to take him 25 minutes to go those 15 blocks. 17. If Bert the Bat travels eastward at 40 miles per hour with a tailwind of 6 miles per hour, what is his actual speed? So we have our little bat. He's traveling eastward at 40 miles per hour. And a tailwind, that means that it's pushing him. So there's a wind also going the same direction at 6 miles per hour. The question is, what is his actual speed? So the bat is flying 40 miles per hour, plus the wind is carrying him each hour 6 miles per hour. So his final speed is 40 miles per hour, plus the 6 miles per hour the wind is pushing him. So he's going 46 miles per hour. And again, eastward. Number 18. Toon train is traveling at the speed of 10 meters per second at the top of a hill. 5 seconds later, it reaches the bottom of the hill and is moving at 30 meters per second. What is the rate of acceleration of Toon train? So we have a hill. Okay. At the top of the hill, okay, the train is traveling at a speed of 10 meters per second. 5 seconds later, so the change in time is 5 seconds. It reaches the bottom of the hill and is moving 30 meters per second. We want to know what the acceleration is. So remember, our equation for acceleration is our change in speed or velocity. Here it's kind of a straight line, so we can say it's speed over our change in time. So our change in speed, this would be kind of our second speed, this would be kind of our first speed. So speed 2 minus speed 1 divided by our change in time. 30 meters per second minus 10 meters per second divided by 5 seconds. 30 minus 10 is 20 meters per second divided by 5 seconds. 20 divided by 5 is 4 meters per second squared. So again, Toon Train accelerates at 4 meters per second squared as it goes down the hill. Number 19, Pete the Penguin loves to sled down his favorite hill. If he hits a speed of 50 meters per second after 5 seconds, what is his rate of acceleration? Hint, he starts at 0 meters per second at the top of a hill. So again, we have a hill, and we have our penguin. Here's my little penguin. Okay. At the top of the hill, his speed is 0 meters per second. At the bottom of the hill, his speed is 50 meters per second. And the amount of time that it takes to go down the hill is 5 seconds. We want to know what his acceleration is. So again, acceleration is the change in speed over the change in time, because again, we're talking about a straight line. So if this is my second speed and this is my first speed, it's speed 2 minus speed 1 divided by my change in time. 50 meters per second minus 0 meters per second divided by 5 seconds. So I have 50 meters per second divided by 5 seconds. 50 divided by 5 is 10, so we have 10 meters per second squared. So his acceleration is 10 meters per second squared. Lastly, number 20, Monster Mike's truck decelerates from 60 meters per second to 0 meters per second in 6 seconds. What is his rate of deceleration? So again, here we have our truck. And initially it's going 72 meters per second. Then it's going to be going 0 meters per second. And we know that this change in time is 6 seconds. It's deceleration, but it's still an acceleration. So it's going to be our change in speed because it's in a straight line over our change in time. Again, this is our second time. This is our first speed, and that's our second speed. So speed 2 minus speed 1 divided by our change in time. 0 minus 72 divided by our 6 seconds. So I have negative 72 meters per second divided by 6 seconds. 72 divided by 6 is 12, and it's going to be negative because it's deceleration. So 12 meters per second squared. Okay, and the negative really is just telling us that it is a deceleration, that we're losing speed and not increasing speed. So that is the corrections for your formula challenge. Again, you need to show all your work similar to how I'm showing it on this video and turn it in. Have a great day. Talk to you tomorrow.